This is the first question of H.C. Verma, Chapter 1. We need to find the dimensions of linear momentum, frequency, and pressure. So, hopefully, this is an easy question you have done yourself, but just in case if you need to see the answers. So, in all the dimensions problem, we first need to find out the formula for it. So the linear momentum is defined as mass into velocity, and then we need to express everything in terms of weight, that is the mass, length, and time. And then if we have electricity, we will also express them in terms of ampere, but just for the mechanical things we have to express them into mass, and velocity is expressed in terms of distance divided by time. So m, distance t, and then divided by time. So m has a dimensional formula m, l, and t is divided by t, so it goes up. Its dimensional formula is mlt to the power of -1. We'll do these things real quick. Frequency is defined as 1 upon time, so its dimensional formula will become t to the power -1. And then the pressure is nothing but force acting upon unit area, and force is defined as mass into acceleration. Acceleration is defined as velocity per time. So acceleration will be L t to the power -2, and area is L to the power L square. So this becomes m L to the power -1 t to the power -2. So this is all about the question 1. It's easy. Hopefully you have done this. Let's move on to question number 2. Here, find the dimensions of the angular speed omega. You will learn about angular speed of omega, but they have given it in the problem here. The angular speed is defined as θ2 minus θ1 divided by t2 minus t1. So angular speed omega is equal to θ2 minus θ1 divided by t2 minus t1. Now what is angle? The definition of the angle is, let us say we make it an angle. If it's an angle like this, and this angle is defined as nothing but the arc divided by the radius. So distance divided by distance. So the angle has no dimension. So all dimension it has is for the time. So this has a dimension of 1 upon t, or t to the power of -1. This is the dimensional formula for the angular speed omega. Now let's go move on to B, the angular acceleration alpha. The angular acceleration alpha is defined as, we are already given this part in this question itself. Alpha is defined as omega2 minus omega1 divided by t2 minus t1, and we have found the dimensional formula for omega as t to the power -1, so this will become t to the power -1 divided by t, so this becomes t to the power of -2. Okay, let's move on to the next one. The torque C, and we are given the torque. If you don't know, you can refer to this problem set. Force multiplied by the distance, that is called the torque. So you are trying to bend something across at an axis, then the multiplication of the force and the distance is called torque. Tau is given by force multiplied by the distance, and force is mass into acceleration. Acceleration is Lt to the power -2 multiplied by distance is L, so this becomes m L square t to the power -2. Move on to the question number D quick. Moment of inertia I, we have already defined this. Moment of inertia I is mr square. We write mr square. We can write it m L to the power 2. So this is simple. Hopefully you have figured it out, all of this. and we will keep doing more problems.